Hello, everyone, and welcome to our zero emission charging safety education webinar. This is the fourth part of our mobile charging solutions webinar. We're going to get started in the next couple of minutes or so, since we have a lot of ground to cover over the next hour. But first, I'll take a moment to introduce myself and review a couple housekeeping items. My name is Claire Hazard. I'm a program administrator on the Clean Transportation team here at Mass CEC. And today our webinar is going to feature certified safety experts to teach us about the safe handling and management practices for zero emission vehicles and permanent and mobile charging equipment. Today, our goal is to equip you with the real world knowledge to reinforce practical safety awareness in your day-to-day operations with these technologies. And before we continue with the slides, I'd just like to take a moment to encourage folks to introduce yourself in the chat. I think we have a pretty big registration list, so it'd be great to learn where everyone's coming from. And as questions arise, please go ahead and put those into the Q&A box down in your toolbar so that we can track those and collect them and make sure we answer them towards the end during our Q&A session. And then lastly, as previously mentioned, when we started out here, this is the fourth part of our mobile charging webinar series. If you missed the first three parts of the series, you can find those recordings and the slides on our webpage. And during those episodes, we had lots of great discussions with mobile charging OEMs. So I'd encourage you to check those out to get up to speed with our mobile charging project and the webinars to date. So in terms of my agenda today, I will introduce you all to Mass CEC. We'll talk a little bit about the EVIC Council, and I'll give you a quick update on our mobile charging solutions program. And then we'll turn it over to our safety education panel, including folks from Better Together Brain Trust and Boston Safety Training. And then we'll finish up with a question and answer session. So for your awareness, or for anyone who may not already know us, Mass CEC is a quasi-state economic development agency with the dual goals of reducing greenhouse gas emissions and accelerating clean energy and climate tech innovation across the Commonwealth. So our work spans across four key focus areas. First off, with emerging climate tech, we have workforce development and large-scale offshore energy deployment. We also have accelerating decarbonization up in the left-hand corner. This is where our clean transportation sits and our mobile charging solutions program sits. We run various programs to make clean energy technologies more accessible across the Commonwealth to decarbonize the transportation sector. For a quick note on our program funder, I just want to talk a little bit about the Electric Vehicle Infrastructure Coordinating Council, also known as the EVIC. In 2024, the EVIC awarded Mass CEC $38 million to run 4 pilot programs with the goal of making electric vehicle charging stations more accessible across the Commonwealth. And when conceptualizing these pilots, the EVIC identified mobile charging as a promising technology that helps fleet owners electrify without the need for immediate large-scale investment in permanent charging stations. In launching this program, our goal is to support the electrification of fleets that do not have access to permanent or traditional charging infrastructure. So these are fleets that are relying on mobile charging stations to start their electrification journey. Throughout the program, we're collecting data, lessons learned to learn how we can make these technologies more available and scalable across the Commonwealth. So in terms of the mobile charging solutions program that we're running, this program has informed a lot of our webinar work in this webinar today. The program will accelerate the electrification of 4 fleets through the deployment of mobile charging stations and zero emission vehicles. Our goal is to increase access to mobile charging to reduce barriers to electrification for the fleets that we're working with. So in terms of the services that we're providing through the program, the funding is covering the deployment of the vehicles in the charging stations. These charging stations and vehicles are being deployed this month, which is very, very exciting. If you follow us on LinkedIn, you will see updates from us. We had one earlier this week to announce the first fleet that received their charging station, which was very exciting. So definitely follow us on LinkedIn if you want to follow that journey. And as of now, the program is fully enrolled. So beyond the technologies, we're also pulling lessons learned to develop public-facing resources to help future fleet owners and operators through similar deployments. To date, we've published our technology inventory, which provides definitions and various mobile charging OEMs to help you get to know the mobile charging industry a little bit better. The other resources that we have on our page right now are our webinar recordings and slides. So please do check those out if you missed them, and would also encourage folks to send those around to anyone you think might benefit from them or might want to learn more about the mobile charging technology. So before handing it over to our panelists here, I just want to take a quick moment to introduce them. We have Nicole joining us from Better Together Brain Trust. We also have Dean joining us from Boston Safety Training. And for a quick note on their backgrounds, Nicole is the president of BT2 and is an energy and climate leader, advancing electrification and decarbonization through her work. She's also a certified energy manager and a water efficiency professional. Dean is the president of Boston Safety Training and is an electrical safety leader, bringing more than 35 years of related experience from the field, and is an authorized OSHA instructor. So as I said before, they'll be diving into real world knowledge to reinforce practical safety awareness to inform your safe handling of these technologies and charging equipment. So with that, I will welcome Dean and Nicole. We're very excited to have them, and I'll turn it over to them.
Hi, folks. Thank you so much, Claire and the Mass CEC team. We really appreciate it. Also, thanks to CalSTART. They're our prime contractor on this endeavor. And thank you all today in the audience for joining us, learning more about zero emission charging safety education training. I'm going to hand it over to Dean just to build on some of the background that Claire had introduced.
So thank you for allowing me to get involved in such an important topic, and it's encouraging to see the state of Mass get involved with the transition to all this clean energy. So I think no real need to get further into my background, with the exception to state that I am a Desert Storm veteran, submarine service, and I'm additionally an electrical safety expert. I've been doing this now for about 13 years, and very excited to be able to share some knowledge around this, and hopefully, sharing some knowledge, we can keep people safe out there relative to the use of a lot of this new technology. Okay. So with that, I think we had, oh, there we go, specific slides to move ahead with. And I think Claire is going to be our clicker today. So some of the themes I think we were going to go through here is why EV charging safety matters, charging infrastructure basics. One thing I didn't do, sorry about that, was put my phone on silent. Little technical glitch there for a second. Bear with me.
No problem. We're also going to be looking at EV battery and electrical hazards.
Here we go.
Operational safety for fleet personnel, charging incident realities, incident response and emergency coordination, as well as continuous safety improvement and resources and questions at the end. We've very content-packed webinar today, but we've definitely reserved some time at the end for questions.
Very good. I think, Nicole, I think we're going to hand it over to you for slides, I guess, to like 10 through 16.
Absolutely. So roles and responsibilities overview. Everyone is responsible for safety, right? I have worked adjacent to Eversource most of my entire career, and their motto is safety first and always. And, that's something that is like a sleeper cell that gets reactivated every time I hear anything safety related. Safety is the prevention of harm or injury to one's health, body, or property. And with knowledge and discussing all the potential risks, we can also learn how to mitigate against those risks, protect our folks, and make sure that there aren't any workers' comp claims associated with any of these things. So we're hoping to provide the knowledge to everyone in attendance today and those reviewing the recording after the fact. Next slide, please. Awesome. Claire, great pace. Fleet owner responsibilities. So the fleet owner needs to ensure that there's compliance with safety training. There needs to be safety training provided and that emergency preparedness is considered. So there are safety regulations, both OSHA and NFPA safety regulations, establishing protocols that promote safe operation and maintenance practices for businesses. They touch upon EV in battery and energy storage in particular as well. So this training is a part of implementing a comprehensive training program. The folks participating in the medium and heavy duty pilot are also going to be receiving individual safety trainings, and it's essential for the drivers, the staff, whomever's interacting with the electric vehicles as well as the EV charging technologies. We can reinforce safety practices, enhance operational efficiency, and ensure that there's also safety training, manuals, manufacturer information, specific information included. Also, emergency preparation, something I learned when my kiddo was in Scouts, be prepared. So effective emergency preparedness helps you develop response plans in the unlikely event of an incident, conducting drills to prepare your response in the event of an unlikely incident, and ensuring personnel are familiar with your emergency protocols and any contacts that may need to be made to public safety responders and that sort of thing. As for personnel and charging operators, they have to adhere to established safety protocols, ensuring compliance with operational standards. Each vehicle manufacturer and electric vehicle charging manufacturer have established protocols and safety materials that need to be considered, and any hazards that are found need to be reported and addressed to ensure a safe working environment for everybody. Electric fleet systems overview. We are talking in particular today about zero emissions fleets. They're usually referred to as electric vehicles, EVs. BEV is a battery electric vehicle, but real world operations vary widely by vehicle type and class. So, if you're talking about a light duty vehicle versus a medium or heavy duty vehicle, more likely found in this pilot, and by larger fleets, then they may have different nomenclature. So one thing is also making sure that when this technology is being spoken about, if you're using acronyms, make sure everyone understands what those acronyms are. Some EV basics, understanding key components and safety awareness. All EVs that I'm aware of have battery systems, predominantly lithium-ion batteries. They are advanced battery systems that store energy. They enable efficient performance and have the EVs of today have much longer range and capabilities for daily travel and different fleet needs. There is a need for high voltage awareness. Operators must be trained in high voltage awareness to understand the risks and safety protocols to prevent electric shock, arc flash, arc blast, thermal and chemical burn injuries. Again, extremely unlikely, but still it's better to have the knowledge ahead of time in the event that a situation may present itself. And then understanding charging types is also important, such as AC, which is your level 1 plugging into a wall, or level 2 charging, and DC fast charging, which is also referred to as level 3 charging. And it's essential for efficient vehicle operation and maximizing fleet uptime, because you need to manage the state of charge of the battery, kind of the same way as when we had ICE vehicles, internal combustion engine vehicles that use gas or diesel or some type of petroleum-based fuel, making sure that your tank is the corollary to the battery, make sure that it has a fullness or higher state of charge. Battery and energy storage systems, excuse me, come in many shapes and sizes and models. Batteries can look like containerized pallets. This picture in the top right of your screen shows, kind of shipping container sized battery and energy storage system. They support enhancing grid stability. They help with grid capacity. They help buffer the charge. If you have a permanently installed charger, they help buffer the grid needs and how that charger feeds from the grid. And understanding the differences between utility connected systems, like I just mentioned, or off-grid systems, allows fleets to optimize energy use, maximize efficiency. It also, using off-grid systems helps folks who may not own where their fleets are parked and dwelling and need charging, um, which relates to a lot of the fleets in this off-grid solution pilot in particular. Again, yeah, battery appearance can vary. There's some on trailers like you see here in the Exos hub, and then there's also the Yoshi Mobility in the bottom right. They're bringing charging in a electric vehicle to the station, to the fleets. Charging models overview. So electric vehicles receive and manage energy in different ways with knowledge of charger types, power levels, connector standards, site design, and load management strategies. You can reduce downtime, ensure that your vehicle is fully charged for the route it needs to be taking when it needs to take it, protect equipment and support reliable operations. And then for more information on charging types, like the level 1, 2, 3 that I mentioned, as well as the different port, like a J plug versus a CCS, which is a combined charging system. It's the plug that goes into the vehicle from the charging station. There is a link here to help disseminate that information. Charging models include permanent affixed to the ground. That's the more traditional, you drive to the charging station, there's a parking spot dedicated to it. Traditionally going through the utility infrastructure process to get those installed, both level 2, level 3 out in the wild in the public. There's also mobile trailer mounted road permitted EV chargers. You see here the HydroCharge, which is really, really neat technology. You have the Exos under that, which is a mobile charging system on a trailer. Then you also have the semi-permanent pad palleted, skid mounted or containerized. This all enables efficient relocation. It is, modular. You can transport it. It's not permanently grid tied. So it gives fleets some options and flexibility in their fleet electrification planning. They're available in various scales, various technologies designed to meet the diverse needs of your fleets. I think I hand it back to you here, Dean. Oh, you're on mute. There we go.
Sorry about that. Yeah, so thank you, Nicole, for handing it over. Unmuted. Hopefully everyone can hear me now. So just a little bit about the hazards that are involved with this newer technology. So it's very important that we understand the hazards that are involved so that we can mitigate any potential harm or injury to one's health, body, or property as a result of these hazards. So that's an important part of this new technology. And we're going to go ahead and identify these hazards, understand some of the risks so that we can prevent incidents, protect people, equipment, and facilities. Now, these hazards can vary broadly from one technology to another, vehicle to vehicle, and fleet to fleet, as well as season to season. So this is not intended to be a very detailed, totally encompassing safety education around this technology. That's some of the resources we're going to give you at the end to dive a little bit deeper. And also, I would recommend the literature that comes from the manufacturers of the different technologies. Their literature is going to be one of your paramount and probably your most important components to learning about the hazards associated with these different technologies. So electrical hazards specifically come in three main forms. So the hazards themselves are typically electric shock, arc flash, and arc blast. And then we talk about different injuries that you can receive from these type of electrical hazards. Now, when we deal with batteries, we also have to consider the possibility of thermal burns, and chemical burns. So a little bit different than just general electrical hazards, okay? Then we have mechanical hazards involved with the specifics of these vehicles. One of the things in learning about like how to recover a vehicle if it's in a crash or something is understanding that these electrical vehicles, they don't make noise when they're running, and they could potentially move without any notice if things are damaged with them. So that's something to be aware of as far as, some of the mechanical hazards that might exist. Typically, it would be in an abnormal situation where maybe there was an accident or something defective with the vehicle. So something to be concerned about there. The thermal hazards that we face typically are relative to output of the battery and or the battery itself failing due to a number of things that we're gonna talk about. And batteries can catch fire, and the biggest consideration with those fires is to ensure that we don't propagate those fires, contain them, keep people at a safe distance, etc. There's also some environmental hazards that we have to consider. Adverse weather, site conditions, they can significantly affect the performance and your safety with this new technology. I think some people have probably heard that in colder environments, historically, maybe they haven't gotten the range that we would normally expect. So that's just one of those things from a performance standpoint that's an effect of the environment. So some specific hazards associated with batteries. One of the big components around these new batteries is they have an intense amount of energy in a small contained space. To get that much energy in a small space, it becomes the energy is now can unfortunately turn into a dissipation of the energy in different forms, one of which is the fire, right? So there's a term that you're going to hear of quite a bit relative to these batteries, and I'm sure you've seen it in the news and social media, and it's called thermal runaway. And thermal runaway occurs when the battery short circuits and starts to heat up uncontrollably. And it occurs if a cell is abused. We have chemical reactions within the battery that generate heat, toxic and flammable gases. The heat speeds up to an exothermic reaction, producing more heat and gases. And the heating continues until the cell produces more heat than it can release to the surroundings. The heat will start now to affect other nearby battery cells. When the generation of the heat becomes self-sustaining, the cell experiences this thermal runaway. It's now an unstable chemical reaction, and it's very difficult to bring under control. In fact, more than likely, if this begins, you will not be able to bring it under control. It'll accelerate. So this now results in a potential explosion, off-gassing, ignition of the cell, and a vapor cloud explosion, okay? So just a graphic image showing like what these cells look like. So if we have one cell affected by a short circuit, typically due to some kind of mechanical damage or some other incidents that we're going to talk about, then the cell failure internally shorts, creates heating neighboring cells. Then we have heavy metal particles, this dark cloud, ignition may occur, and we have now the battery fire as a result of this thermal runaway. So there are other hazards associated with these batteries. So I want to just address those first. When we start speaking of electric shock relative to these batteries, that shock risk is very low. The reason for that is the battery is a DC cell and its only reference is to itself. The high voltage components are not related to the chassis of the vehicle. The high voltage components are typically isolated from an airbag deployment and other things. So they're relatively safe from a shock standpoint. It's different from AC current, like your household and industrial type voltages, where they have an earth ground reference. And that is why that one becomes more dangerous relative to people in electric shock. You can easily become part of the circuit because we're typically in touch with ground and we become a part of the path for the electrical circuit and an AC circuit as a return point to the source. And that's how we get an electric shock. Relative to the DC batteries in these cars, because it's self-contained and not relative to the chassis of the vehicle, you are very unlikely to receive an electric shock. The arc flash and arc blast are also similarly unlikely to occur due to the nature of the construction of these vehicles and the safeguards they've put in place. Personally, the only battery arc flash events I've been involved in were industrial related environments with swapping out UPS batteries. And I had an incident with a motorized pallet jack where someone had a failed connector and it arced and they ended up with some minor burns. So EV, when I looked into this, I didn't really find any relative injuries as a result of arc flash, arc blast, and electric shock, again, is extremely low. So the one concern realistically in our research that we want to share with you and make sure, and again, it's also very unlikely to occur, but we have to make you aware of this hazard, is the thermal runaway. All right. The thermal runaway is something that is, if it occurs, it's self-sustaining. The batteries themselves have the fire triangle. They have a combustible source of energy, the material, they have oxygen, and they have the heat as a result of the internal failures. So if we do enter a situation, which is very unlikely, where you have a thermal runaway with a vehicle, it might be noticed by smoking. You might hear hissing and popping noises from the, it might be, it's not operating properly. The focus now becomes on dissipating the heat, preventing propagation, minimizing your exposure to flames and gases, and notify the emergency responders. They are trained to respond to these events. So again, it's super unlikely. In fact, our research has shown that these events are so very low likelihood events. But again, we wanted to make sure everyone's aware that it can occur, and more than anything, I think because it's so prevalent out in our society from social media and regular media, that we wanted to address that concern in this and let you know what that term thermal runaway actually relates to and how it may occur. All right. So the battery hazards, once again, the risks are electric shock, arc flash, and arc blast, super low likelihood. We reduce those risks through engineering controls like the installation of the equipment, finger-safe terminals, and isolation and guarding. So very unlikely you're at risk of any of those components of the hazard associated with the EV vehicles. The electrolyte exposure, again, super low likelihood. Modern batteries that are in the electric vehicles contain almost a dry cell in essence. Unlikely that you would ever be exposed to the electrolyte. But if it were to leak out for maybe an instance of an accident where you have breached the containment of the battery, then potentially some of that could come out and you would see it as a clear liquid. So just recognize that that's something you don't want to touch. You want to stay away from it, notify the authorities, the emergency responders. They're trained to deal with that. So again, that's a very low likelihood thing that you would ever get exposed to electrolyte. So we're going to remove the possibility of any chemical burns, okay? So some of the key practices that we want to recognize, vehicle positioning. Make sure when you're pulling in and out of these charging stations, you're aware of the area and you're not putting the vehicle in a position where you're going to have to stress any of the cables that are going to charge the vehicle or pull cables across other equipment to charge vehicles, etc. That you're not blocking pedestrian traffic, things like that. Then cable management, that's another thing. Make sure that we're organized with the cabling system so that we're not creating trip hazards and we're not damaging the charging stations themselves. So there should always be a little slack in these charging cords to ensure that we're not putting any strain on any of the connections. And then as far as PPE, we're really not advising any special personal protective equipment at this time relative to the activities that you're going to be doing, charging the vehicles. That's more towards maintenance personnel and first responders where there's abnormal conditions where there might be a need for personal protective equipment. But under normal conditions, we don't expect any requirement for any special personal protective equipment. So some of the key practices for operators, I think, Nicole, we were going to maybe hand this back to you.
Yeah, absolutely. Again, that high voltage awareness that had been mentioned, the systems should be operated by trained professionals or folks that are aware of how to interact with the charging equipment and the electrical vehicle. The same way that you're supposed to be a licensed driver in order to fuel internal combustion vehicle at a fueling station. Operators must understand the dangers associated with the high voltage systems, as Dean had mentioned. Unlikely to have electric shock. Arc flash should not be happening unless someone is messing around with the electrical distribution equipment. And blast hazards as well as thermal and chemical burns, again, extremely unlikely scenarios, but things that should be, considered in your emergency management plans. safe shutdown. There's proper procedures that have to be followed for safely shutting down the systems to prevent accidental energization. Lockout tagout procedures that are ubiquitous in electrical safety scenarios, and making sure that all personnel are aware of proper shutdown processes or proper procedures. You don't want to leave your charging cables laying around on the ground so they can be driven over, or we get 3.5 feet of snow again and they're covered and it's getting plowed into by a metal plow blade. It's also important to have situational awareness, alert to environmental conditions, inspect the cables. Are there nicks? Are there cuts? Is the plug inserting into the vehicle properly? Is the connection being made so that way the energy can transfer? If something is not the usual, it's good to be aware. I'm guilty of it myself. I have an electric vehicle, and at a charging station, I'm usually on the phone or, talking to somebody while I'm plugging in or something like that. But it's good to be fully aware and present when you're going through the motions and in this procedure. Let's see. Yeah, do's and don'ts. There's no one size fits all checklist for ensuring operator safety, but there are consistent starting points. Again, kind of going through the motions, talking through it, and having a known procedure discussion with the fleet owner, knowing what the kind of secret handshake is. Every time I go to a different charging station, permanently installed charging station, it's like a different secret handshake to get that thing to connect to my vehicle and dispense the energy. Do I swipe my phone? Do I use my card? Is it plug and charge? That sort of thing. So a lot of these operators, you're going to also be interacting with public charging stations, not just the charging station for the fleet. If you need to refuel midway through a route or something like that. So, having a plan in place, having knowledge of how to interact with the equipment, and following these other safety items that we've discussed today and continue to discuss. Do's and don'ts: understand your role and responsibilities, don't exceed your training and knowledge, and read and understand the manufacturer's literature for your specific equipment type. There's, some vehicles work better with certain technologies than others. So kind of knowing the fleet vehicle that you're driving, is important, especially as personal operators, folks who just own their own light duty vehicles. It's helpful to know what can be expected when you approach a new charging situation. EV charging basics: use only compatible equipment. So one big thing here is the back to the charging types that we touched upon briefly, and we have some great links in the chat from Devin about the charging types. There are different charging protocols, different plugs and connectors, and there's also adapters. So it's really important to use OEM approved, original equipment manufacturer approved equipment. So for instance, I drive a Hyundai Ioniq 5. I'm also a business owner. So if that's, a fleet vehicle that my folks are driving, I want to make sure that they're able to charge in many scenarios. So there is a Hyundai approved charging adapter, so that way I can charge at a Tesla station or a station that uses what's called the NACS, NACS, North American Charging Standard is what it stands for. It's a different configuration for the plug, but I make sure that I have the OEM approved piece of equipment, because aftermarket might not be UL approved and listed. It might, have an overheating problem and cause charging faults or something like that. Something else important to do: inspect all equipment, hardware, cable, connectors for damage before use when you're interacting with the charging station. I often am on different charging apps reporting when equipment is, malfunctioning, or, it got run over by a vehicle or something along those lines. I think there's less. I used to work at a gas station, a mobile gas station in high school, and we used to have folks drive off with the pump still connected to their car, still in their car. So that would have its own emergency response that we had to do. But I think now it's much less likely with electric vehicles. I can't even start my car and drive away if I'm plugged in still. So that's, there's some fail safes here, which is great. Use extra care in wet environments. One of my favorite myths is that you can't charge your car while you're standing in a puddle. All of that authentication and connection, the electrical stuff happens in kind of in a vacuum between the vehicle and the charging station. So you standing in a puddle while you plug it in and walk away is not a problem. And then cable management, super important. There's a lot of charging stations installed out there where they don't have cable management inherent. So there's not like a retractor or something like that. So kind of like, return your shopping cart once you're done loading up your vehicle. Also wrap the cable management, wrap it back up, put the plug back into the station to be a good steward to and for the next person too.
All right, I guess I'll pick it up from here, Nicole. So some of the EV charging equipment specific do's and don'ts, overcurrent protector devices. These are fuses, circuit breakers, maybe the line side supply of a charger could have even a ground fault circuit interrupter for the AC component to the charger. These are devices that operate for a reason. There's either an overload condition or a fault condition, and we need to understand why that device operated before we go ahead and reset that device. Now, you can only reset a protective device if you're authorized and qualified to do so, and that would be at the direction of your employer. So if you've been trained and knowledgeable and you can discern the difference between overload, a fault condition, how to rectify those conditions, then as a qualified person, then you could reset that device. But it's very important that if you're not qualified and authorized, that you're going to have to get someone who is knowledgeable, qualified, and authorized to investigate the issue before that protective device is reset. Again, they do trip, they do open for a reason. They're designed to do so under different conditions of either overload, ground fault, and/or fault. So it's very important that we don't exceed our training, exceed what we're allowed to do, understand what your limitations are, because you could definitely create problems for either the equipment, yourself, or others if you're doing this and not entirely knowledgeable. Okay. So, one of the things that I thought of when we were putting this together was sharing real world knowledge about events that actually occur at charging stations and or with electric vehicles. Now, I want to be very clear up front that the information that we are putting in relative to events for electric vehicles, charging stations, super low likelihood. They're very uncommon to occur. In fact, when electric vehicles first started out, there was a little sensationalism in the news where car fires, this, that, and the other. I'll be honest, I thought about it recently when we were working on this, and we really haven't seen a lot of that lately. So a lot of that sensationalism is gone, and I think a lot of it was exactly that. They were super low likelihood events. They were extremely rare, but they were sensationalized. So with that in mind, understand that these events are super rare. For the most part, operating these vehicles, they operate for many miles without incident. But understand that incidents can occur, and we want to make you aware of some of the type of things that we have seen, and then what type of results have occurred, and then maybe some of the actions to take. Okay. So charging alone does not inherently increase fire risk. That's a misconception. Okay. Now, although incidents at charging hubs are very unlikely, there's a need for emergency response planning. You got to know things like on-site hydrants, fire apparatus access, knowing who to call if there is an event through pre-incident planning. Now, some of the other concerns are effects to the environment. One of the things we're trying to do here is be good to the environment. So it's also a consideration of if we are going to have to suppress maybe a fire, thermal runaway, what's the runoff, right? So these are concerns. Now, when properly operating road registered EVs, overcharging to the point of fire is almost impossible when you use compliant, professionally installed charging equipment. Now, Nicole hit on something that kind of rung to me, and it was making sure things are like UL listed, compatible. Those are important things. A UL listing means that in a nationally recognized testing lab has actually gone through specific testing of the equipment, and they know it's going to perform as designed, and it's not inherently putting people at additional risk. Okay, so that's an important thing. So if things are installed properly based on the code, qualified people, incidents are super unlikely. Okay. Most charging connected fires are believed to involve vehicles that were previously damaged prior to the charging.
So Dean, can I just press on that for one
Sure.
moment? So it's if it's a vehicle that was previously damaged, it's likely something that was damaged in some type of accident and maybe not repaired properly, something that may have not been caught at that time.
True.
Yeah, thank
Or maybe you hit some road debris. Like there's a number of
you.
different things. Submersion in water. I think we might have some slides relative to that, or maybe those got pulled. I forget.
Yeah,
So,
I think those were hidden, but we can talk to them at the end if we have extra time.
okay. So, real world events vary in severity, cause, complexity, and required response from equipment faults to thermal events, utility disruptions, even compounded events. Sometimes it's not only one thing that's occurring. We could have multiple events occurring. So knowledge of your system, the charger, your equipment, knowing what types of alarms and indications you might have, knowing the proper shutdown procedures for the equipment to make it safe. And there could be situations where we have to evacuate. So understand what those routes are. Coordination with emergency services is very important, and that begins when you're going to install or bring this technology to a location. That the emergency responders that will respond to an event at that location, they need to be part of that right up front. So that's something you're going to communicate to them when this technology either arrives or best even ahead of its arrival. Then they're aware of it. You get the technology. The first responders have an opportunity to meet with you, understand that technology and what type of response that they might need to render for that. So that's a great thing up front. It can reduce confusion, limit escalation, and it's going to protect people and assets if the first responders actually know ahead of time what they're dealing with. And they might even have to procure additional resources or equipment, something that they might not currently have. They might have to train people additionally to be able to respond to these events. So getting ahead of it is a very important thing.
I think that's also particularly important for off-grid charging assets that may not go through a traditional permitting process.
Hmm.
So that's thankful, really a really helpful bit of information. Want me to take over, Dean?
Oh, sure.
Okay. Recognizing emergencies, identifying key indicators of potential hazards. We strongly suggest employers establish an emergency action plan for the response to all emergencies that workplaces may see. But also, if you're electrifying your fleet and have charging equipment on or battery and energy storage systems or any off-grid or mobile charging solutions, have a plan to respond to the emergencies. And also notifying public safety personnel that may be responding in the event of a risk or emergency. They might be able to help you pull together an emergency action plan. I think we have some other resources. I'm getting ahead of myself. Other resources on another slide. Personnel should also be trained on these plans. Growing up, we had fire drills in elementary school, high school, what have you. So we knew exactly what to do. Also, I went to Mass Maritime Academy, so we had safety was very important. We had safety drills all the time. I got to wear a Gumby suit and jump in the ocean and learn how to deal with that. So, it doesn't mean the training can't be fun. And include in your emergency action plans response to abnormal equipment conditions. I think Dean had mentioned swelling of batteries or, any visibly damaged equipment. overheating, smoke fires, equipment physical damage. I think too, the ground fault circuit protectors, if something keeps tripping during operation, that might be a leading indicator that there's something else going on between the systems to kind of investigate further. Obviously, visual alarms like flashing lights or audible alarms serve as crucial alerts for immediate attention. Not all systems have them, however. Smoke absolutely is a signal of fire or overheating equipment. It necessitates urgent evacuation and investigation to ensure safety. And then heat, also elevated heat levels. A lot of the battery and energy storage systems that I'm aware of have heat sensors that'll set off an alarm if the heat is elevated above where it's expected to be. And the heat can prompt operators to check systems and make sure that everything's good or not. Emergency plan assistance, how can you get started in creating your own EAP? OSHA has a resource here at this link. The NFPA, National Fire Protection Association, has a standard. There's also federal help to develop emergency plans. I think to reach out to your local public safety professionals, the fire response teams, and again, I'm getting ahead of myself. I include this in a different slide, but it should be here. I think also talking to your general liability insurance company or your automobile insurance company about support in adopting a safety culture and having emergency action plan where one may not exist, or to supplement it where it exists and you have additional things that need to be added. I know I don't like paying a lot of money for my general liability. So if there's things I can do that they approve of, obtain safety training certifications or have certain safety protocols in place to reduce my general liability premium, then I'm looking to do it. Sustaining a safety culture, practice, practice, practice. So the safety drill is really important. Making sure that there's ongoing education and professional development. As new staff come on board, make sure they're trained in the things that existing staff have been trained in. It's not just operators of the vehicles of the charging equipment that need the training. It's the whole all of your employees, all the folks at where these fleets are electrifying. Add space for reflection, adaptation. Yeah, okay, so you have one piece of mobile charging equipment, and then that lease or your contract there is up and you want to try a different one. Make sure your safety materials reflect that change, that your training is reflective of the considerations of that new technology. And it's a shared responsibility again. We had mentioned what's the fleet owner's responsibility, what's the operator's responsibility. It's everyone's responsibility. Key aspects of safety trainings for fleets, target audiences. We really we're targeting fleets here today, supervisors, maintenance personnel, contractors. The safety training can be tailored to any audience. Make sure there's regular training sessions. Excuse me, sorry, sorry about that. I'm recovering from pneumonia. Training frequency. You want to have regular training sessions. Safety culture is not something that's one and done. It's a practice. Make sure there's refreshers across all safety considerations for your organization, but in particular here, fleet operations, charging. Make sure you do incident reviews, see if there's ways that those incidents could be mitigated or avoided, and also make sure that there's accurate records of the training sessions. Those are things I think like your general liability insurance company would want to see. Make sure participant attendance, completed assessments, our employee handbook, you got to sign off on it. You got to make sure the same thing with our safety handbook. And yeah, keep those document records. Dean, I think I'm handing it back to you.
Sure. So some of the training resources include things like manufacturer's literature. Again, that's number one. That is something that you can't bypass. Definitely start there, right? Now, one of the things I just wanted to mention around manufacturer's literature is The equipment itself also is going to have labels. I recommend reading all the labels that come on the equipment as well, because sometimes that's a little more intuitive, it's more in your face, and it might even cover things that might not even be necessarily covered in the manufacturer's literature. So I found that to be true in some instances. So number one, manufacturer's literature, but also on the equipment, you're going to see warning labels, informational labels, et cetera. Those are important to read as well. Nicole already spoke of general liability insurance company assistance. Then we have things like consensus standards. NFPA 70E is about protecting people from electrical hazards. All right, so it's an ANSI standard, it's a published best practice, gives you an education about electrical hazards and then safe work practices towards minimizing risk with those hazards. So that's a great standard for everyone to be familiar with relative to the electrical hazards. Unfortunately, the NFPA currently doesn't publish one overall electric vehicle standard. There's a lot of different training available from the NFPA. There's different standards that address things like the safe installation of the equipment. But overall, there is not currently one like electric vehicle standard. I think they might be forming a committee. They're progressing towards that, but it's not currently something we have available to us. And then we have private companies that do training, like myself. So there's others out there. I just happen to be involved with this today, so my company's in here. Then we have global resources. Through my research in assisting Nicole and the group here with this training, one of the most comprehensive resources that I found around electric vehicles, vehicle safety, education around electrical vehicles, the technology, is this right here, EV FireSafe. It's an Australian organization. They're actually funded by their Department of Defense. And it is, to me, from my research to date, the best resource overall for electric vehicles, the technology, safe work practices, and understanding of hazards, risk. It's probably the one thing that I would say as a great starting point for an overall education around this technology and to really help you out. Okay. I think a couple of other things I just wanted to mention real quickly as we were going through this, and it can be related to almost any slide, but near miss reporting. This is an important component of overall safety. That if you see a problem that could have caused an incident, and you correct that, that needs to be shared upstream in your organization because it might not be an isolated incident. And your observance of that and sharing it upstream, maybe that same instance occurs across the organization and now it can be taken care of at the other locations as well. So I just wanted to really just bring up near miss reporting as an important thing that we all should be doing. It's extremely helpful. Sorry about jumping back there, Claire. Go. Yeah. Okay. So effective fleet safety requires collaboration between electrical, environmental, emergency programs. We need to ensure that comprehensive training and protocols prioritize safety while addressing the diverse operational challenges across all scenarios. So there is a lot of different technology out there. They covered the different types of charging stations. There's different types of vehicles. There's hybrid, there's straight EV. There's other technologies out there that are zero emission, right? This one happened to be focused on electric vehicles. All right, so Nicole, maybe we'll hand it back to you for a little bit of a closeout.
Yeah, absolutely. I'm actually going to hand it back to Claire. I believe there's one more Mass EC kind of thing, but I will give a shout out to, in advance of them mentioning it. The NFPA, in collaboration with Mass EC, has a training. They're free with special codes, and they're right here. I took both of these trainings to help prepare me for today to present, and they were immensely helpful. I highly recommend them to any folks doing electrification in search of alternative fuel vehicles. And also, it includes PV solar safety as well as battery and energy storage.
Excellent. Yeah, thank you so much, Dean and Nicole. Nicole, I don't think I could have said it better myself on the NFPA trainings, but yes, here they are. You can access the trainings via these QR codes. And like she said, if you pop in the Mass CEC codes, you'll have access to these free trainings. And again, they're online, self-paced. You can take them at your leisure and you'll receive a certificate if you complete them. So highly would recommend those. And then we also have our Mass Fleet Advisor program, another program we wanted to flag for any fleets joining us today. So the MFA program provides free technical assistance for medium and heavy duty fleets interested in exploring their fleet electrification options through personalized fleet electrification reports. So if you'd like to learn more, check in about your eligibility, or even sign up for the program, I'd like to invite you all to visit this link to learn more about the program. And again, these slides will be posted to our webpage following the event. So all of the links, resources, and QR codes that we've reviewed today, you will have access to following the event. And with that, I think we have a couple questions in our Q&A box. So I'll turn it over to Devin to help facilitate the Q&A session.
Hi, everybody. So we have two questions that I'm hoping we can answer in 5 minutes. The first is from David, and he says, can you address electric/hydrogen hybrids and any special considerations?
This is a little outside of my wheelhouse. I focus predominantly on electric vehicles, electric charging infrastructure. What I do know about hydrogen vehicles is that the, public refueling infrastructure is pretty sparse in Massachusetts. I'm not sure if there are even any public hydrogen refueling stations that I'm aware of. It doesn't mean they don't exist, but I know very little here, so I apologize. I can't be super helpful. We can try and follow up after the presentation once I have a chance to review resources that I have at my discretion.
Nicole, I might say we have our one of the pilots in the program is actually using hydrogen as their mobile charger. So I might have our CalSTAR team also help out with an answer after.
Oh, yeah. I was taking this as electric and hydrogen hybrid vehicles in particular. I was aware of the hydrogen charging, off-grid charging solution. But maybe David can provide a little more context to the question so we can make sure we're answering the right one.
It's a great point. So thank you for catching that. While David potentially types, let's move on to the next question from Caitlin. So it says, for many years, warehouses have had charging stations for forklifts and other material handling equipment with lithium batteries and other battery technologies. How is planning for warehouse MHE different than what was presented here for fleet and personal electric vehicles?
I'm gonna tag Dean in here, but I'm gonna have a little preamble. My understanding about forklifts and material handling equipment, they have smaller batteries and they tend to just plug into a standard wall outlet in the respective locations where they're charging. They may have a specialized charger, but it's traditionally smaller batteries and charging that is conducted internal to the building's electrical systems. So when we're talking about fleet and personal electric vehicles, they typically have much larger batteries that need to be plugged into for longer to get to that full state of charge. Dean, what's your take there? On material handling equipment that's been electrified versus larger fleet vehicles?
I think the technology is very similar, right? The only difference I kind of thought of when I was reading through the question is the fact that a lot of this technology is going to be in outdoor environments, and it just becomes now the emergency response planning that's now different because of the diverse environments. That's probably the biggest difference because the technology, the equipment's very similar. Someone in a warehouse as an employer would still have to educate and train their people. They'd have to be knowledgeable about the equipment, how to charge safely, what the different hazards are, which again, they're similar. They're going to have to have an emergency response plan and have notified more than likely their local responders that they have this type of technology and equipment there. So it just becomes the fact that this is now mobile technology being deployed maybe in parking lots and different environments. It's not as controlled, and it just becomes a matter of managing that component of it a little bit differently. I think that's really the only significant difference, other than what Nicole stated as the scale is obviously a lot larger. That's all.
Okay, well, thank you, Dean. We had one more question come in, so let's see. It is a bit of a doozy, so let's see if we can answer it quickly. If not, we can always follow up. It says, we've seen some thermal events involving electric school buses in New England. One occurred last night in Vermont. They appear to be non-battery related. Do you have any insights on what went wrong? What are your recommendations for stakeholders who are concerned about deploying EVs after learning about these events?
I'm gonna press for more context. So by thermal event, does that mean a battery fire? Um,
I'm assuming so, but I don't know.
Well, they stayed in here seems to be non-battery related. So in the research I had done previously, the incidence of battery fires relative to internal combustion engine fires is they're almost non-relatable. The numbers are so significantly different, where there's a lot more vehicle fires with internal combustion engines than there are electric vehicles. So if it's a hybrid bus that had a thermal event, I mean, more than likely it was related to something other than the battery.
Okay. And then Claire's going to close us out.
All right, well, thank you so much, Nicole and Dean, for joining us and sharing all of that very useful information. Just as a reminder to anyone who joined us in the audience, our first three sessions are all live on our webpage, so please check those out if you missed them. This will be uploaded shortly as well, and we'll let you all know once it's live. And then coming soon this summer, we're going to cap off this webinar series with an update from our mobile charging pilot. We'll share some lessons learned and some updates on those deployments. So thanks for sticking with us. Again, thanks, Nicole and Dean. And we'll be in touch with more resources soon.
You're welcome.
thank you. Be
Thanks,
well.
everyone.